All right, please make your way to lesson 4. It's actually a pretty light lifting day compared to other fourth lesson from the chapter type of things. So make your way to bubble 1. And you'll see our goal is to recreate this rock, paper, scissors app. So the app is pretty basic, pretty self-explanatory. User chooses something, computer chooses something. The result is placed up at the top, or the scores are kept and whatnot. Okay, so let's go to bubble 2 and actually make it. When you get there, you will be happy to see that it is almost completely already written for you. Okay, which is nice. I guess I would have liked to have built it myself, but that's fine. It I don't know if you noticed the layout has changed, colors have changed. I don't know why, but either way, you'll see that we have pretty familiar layout. We have some global variables at the top, including 2 lists. We have some event handlers that all they do is call the update screen function, but send a different parameter each time, depending on the button. Rock button sends rock and so on. And that update screen function is the major part of this app. It's receiving a parameter, which is whichever string comes through, and uses that parameter in the result of this. What we need to do is fulfill or complete these 3 return functions in order for it to work. Okay, you'll notice that they each are well documented with comments, okay, in a format that will look familiar or will be expected moving forward. A description of what it does, the parameters it's expecting, including the data type, and what is being returned, including its data type. Okay, and we could solve these in any order, but in order for us to test things like who's the winner, we need the computer to choose one at random. Same thing with find icon. We can't have find an icon until we know what the computer has chosen. So that's the one we are going to work with first, and it's actually the one that comes up first as update screen runs. These 2 local variables are declared and initialized by calling a return function. And whatever the result of random choose is, it becomes that variable and is used the rest of the way. So how does random choose work? Well, it sends a parameter, choices, which is actually this global list, this global variable list that doesn't technically need to be sent as a parameter, but whatever, it's good practice. And so it sends the entire list of choices, and it gets received by the function and put into a parameter called list. we need to figure out a way to send back one of the items in the list. Always a good idea to set up with a container to hold the thing we want to send back. And the thing we want to send back isn't an index chosen at random. It's an item chosen at random. So how about just rand item? That's a good name for it. And whatever comes up, that's what we're going to be returning. So we can go ahead and put that in the return. But what is rand item? Well, we get a list and we want to pick an item from it. So random item is going to be a list at index, and then I'm just going to put a space holder because we want to choose a random index from that list, and any list is between 0 and list.length -1. So this is choosing a random number that corresponds to an index on this list called list, and it is getting the entire item. We are returning one item from the list. Once we have it, we can send it back. So this entire return function, random choose that sends choices, will turn into one of the items from that list, and we can prove it. Well, I should say we should test it by doing a console log statement of computer choice to make sure it's working up to this point. So we hit run now, and we click on any one of the buttons. And you can see, even if I click on rock every time, it's going to return a different. Oh, I didn't get any scissors. That's a long time for no scissors. You can see we're getting a different return each time. And that's our goal for this point so far. Okay, we know the computer is getting one of the strings at random. Great. Okay, next, we need to decide a winner. All right, and I can just leave this here for now, it's fine. So decide winner sends two parameters. The player's choice, which is received here as a parameter and sent here in the when the buttons are clicked, whichever one gets placed into there, and it gets passed straight through to there as the first parameter in decide winner. And the other one is whatever got turned into, whatever computer choice got turned into. So this is the decide winner function. It is a an algorithm. Okay, we're going to compose an algorithm that solves the rock, paper, scissors game. Okay. So how are we going to do this? Well, we are getting a choice from player choice, which is going to be a string, either rock, paper, scissors. And we're getting computer choice, which is a string, rock, paper, scissors. And we want to return either draw, player, or computer. So how are we going to check this? Well, there are three choices for each, but no matter what they choose, if they're the same, it's a draw. We don't even need to know who sent what. We can just check to see if they're the same. And if player choice double equals computer choice, return draw. And there's a couple ways to do this. We can do our sort of container thing where we declare a variable like winner, and then our result will be returning whatever winner is. Let's do it this way, I think. The alternative is putting return in each location. No, let's do return in each location. Change my mind again. Okay, so the thing about having multiple return calls in the same function is you have to know that it ends the function. And if you have some sort of loop, or you're expecting something to happen after, if whatever path the conditions take goes to a return, it will return that, but then it will stop everything after it. So just being aware of that is useful. Okay, so we obviously have other outcomes, and we could go through and do them all here. I'm going to put it in a separate conditional just to make it more visually simple. And it's fine that it's past this first if, because if this is true, it's going to return draw and ignore everything after it. So there's that. Okay, we have 3 options for player and 2 options for computer, because no matter what player chooses, if computer has chosen the same thing, it's already gotten knocked out by this first condition. So we're going to do it this way, where this top if else are going to be the player's choices, and then the computer is going to be if else's inside of them, because there'll only be 2 options. So let's go through and say, let's do the player's choices. So if player's choice double equals rock, spelled and capitalized identically. Okay, the other player choice is if player choice double equals paper. And the last one, we know it's scissors. Contextually, it can only be one of the 3 things. So we check paper, rock, paper, player, rock, player, paper, and then the last one has to be scissors. Now, inside of this first conditional, there are 2 options for what the computer sends. The computer can't send rock, because if they sent rock, if the player chose rock and the computer sent rock, it would have already been knocked out. So here we are checking computer choice double equals paper. And this else has to be rock, scissors for player and computer. It's the only way that anything could have gotten here is if player chose rock and computer chose scissors. So we want returns for these. Okay, player rock, computer paper, computer wins. And otherwise player wins, because that would be rock versus scissors. Okay, so next one, the 2 conditions if player chooses paper. If player chooses paper and computer double equals rock, computer rock and player paper means the player wins. Otherwise, the computer wins. That is player against scissors is this last one. And this last one from our top level if else situation is, and in fact, I'm going to put some white spaces in there so you can see a little better. I'm starting to feel like it's a little crowded. You don't have to put the white spaces. Whoa, don't do that. Like that, and then we'll go like this. Okay, so this, hopefully that helps. This last condition, the else condition for the player's choice, means the player has chosen scissors. Otherwise, it wouldn't get there. Then we just need to compare against the 2 options computer has at this point, which is computer chooses rock, or and then the other one is has to be scissors for player and paper for computer. It's the only way it could be there. And so if it's scissors against rock, computer wins, and if in the other scenario is player wins. And if this gets kind of confusing, just sort of go with it for now. But a lot of times you can just sort of walk down the path where if it's in there, it's that, or it goes down, it goes there, and so on. Maybe it's easier to see it in text. Sometimes the line justification is actually easier to see. A lot of times you'll see them put the open curly bracket on the same line. Wonder what text mode will do for that. What the else is here? This is not an uncommon way to see conditionals. And let's put it back because it'll look different for you. Of course it doesn't. I think that should look right. All right, so we have our function for receiving two options or receiving the two competitors' choices. And we want, no matter what happens, we're going to return something. Okay, and so we can test this by doing a few console log statements, always a good idea. Let's console log computer choice, player choice, and winner. And let's see if it's right. Okay. Oh, shoot, I'm missing something. I delete a, where is this supposed to go? Missing one. Oh, all right. Well, there we go. Anyway, we throw rock, scissors, player wins. Now, obviously the icons aren't right, but we're pretty much there. We throw rock, they throw scissors, we win. We throw rock, they throw paper. Hold on, do I have computer going first? Or player going first? I throw rock, they throw paper. I must have this backwards, because I don't think that is the logic there. Okay, rock against paper. Computer wins. Otherwise, it's rock and scissors. Paper against rock. Player wins. Otherwise, it's paper against scissors. Computer wins. And that's scissors against rock. Computer wins. What am I doing wrong here? Maybe I'm just misreading it. Rock, draw, good. Rock, scissors. I rock, their scissors, player, good. My draw. My rock, their paper. This should be. I have this backwards. What's going on here? Rock, paper. Something's wrong. What's that? Oh, yeah. There we go. That makes sense. Thank you. The inner one has to be computer choice. Good catch. And that's why that is that way. Okay, excellent. Okay, so we have our logic working. We just need to get the correct icons to show up when we call it. And how are we gonna do that? Well, we have a function already set up for us called find icon, and it receives a parameter called icon name, which it's really more like the icon we want to return. You know, go find this icon, because what we're actually sending is whatever string, either rock, paper, and scissors or scissors, is what we're sending as the parameter. And we want it to turn into the string that corresponds to that picture, and that's why it's in a set property and image property. So how are we gonna do this? Well, we are receiving a string, which is the word rock, paper, or scissors. And we need to traverse the list called choices until we find a match. And if we find a match, we want to return whatever is in the icons list at that same position because they are lined up on purpose that way. So we've seen this a few times, once or twice. So inside the find icon, let's we need to loop for sure. And let's loop through. I mean, we could do it 3 times because we know it's going to be 3 times, but let's just loop through the choices list dot length number of times. And choices again is a global variable. We're not getting it passed as a parameter, but it's fine. So we're going to go through the entire list of choices and check if the thing we're looking at, choices index I, is the same as whatever got sent as the parameter icon name. We have a match, and we want to return whatever's in the icons list at the position that we got a match. Icon I. Icons index I. Okay, this was all over the last unit, traversing multiple lists, but we're searching through the choices list to match whatever we send it, and we're sending back the item from this list at the same position. So this entire function call, this return function call sending a parameter, will turn into whichever one of these we want it to. And so now we click go, and it shows you what you throw and what the computer throws. I'm getting a ton of draws, but there we go. Okay, and that's actually it. Okay, not too much work. Does anybody still need to see this on find icon? Oh, my mistake was the inner conditionals are all computer choice, and I had player choice both times. Yep. Any other questions? There is another way to do this conditional that, I mean, it's a simple game. There's a lot of ways to do it, but we're gonna stick with this. I think this is a logical explanation. Yeah, instead of making you do it, I'll just show you. The other way you could do this conditional would be to essentially, it will still knock out any of the draws, but go through and figure out all the ways that the player could win, which there are 3 ways a player could win. And if it's not a draw and it's not a player win, it has to be a computer win. I don't know if that makes more sense, the way you think about things, but I guess technically it's fewer conditionals. It's just another way of thinking about it. All right. Now, are there any questions? All right, that's it.